James Webb Space Telescope, people have been working on this for over 25 years, was because, as the saying goes, they needed a lot of miracles.
For decades, Bill Nye, the beloved science guy, has piqued our interest in the cosmos, making the vast world feel a little more accessible. We're taking pictures of these objects with astonishing precision. Now that the James Webb Space Telescope is capturing amazing photographs from over 13 billion years ago, Bill's joy is apparent. Come with me today as we explore the vast, wonderful world of outer space. These pictures have the potential to revolutionize our understanding of the universe as well as our perceptions of life. The James Webb Space Telescope, already regarded as a viable successor to Hubble, promises groundbreaking discoveries. James Webb will go where no other telescope has gone before. To catch more photons, a bigger mirror was needed, 7 times the size of Hubble's. So what fresh discoveries are being made, and how does Bill Nye perceive these cosmic wonders? Let's look at the latest celestial disclosures. The creation of the James Webb Space Telescope, also known as Webb, is the result of years of hard effort by NASA scientists and engineers. The telescope was launched on Christmas 2021, and its deployment over the next few months was a painstaking procedure that went ahead without a hitch. By late June 2022, the telescope was operational, and scientists made incredible findings within days. Thousands of new galaxies, older and farther away, began to appear. Some of these galaxies were found to be more than 150 million years older than the oldest galaxies observed by the Hubble Space Telescope. Webb's unparalleled ability to collect light from astronomical objects like exoplanets and developing stars enables it to reveal their compositions and motions across space. Bill Nye underlines that Webb's data has already begun to reveal the atmospheric makeup of planets hundreds of light-years away, implying that they may be capable of supporting life as we know it. The Hubble Space Telescope recorded one of the most iconic pictures of the Eagle Nebula, known as the Pillars of Creation. These towering clouds of gas and dust, which are centers of intense star formation, have long captivated astronomers and the general public alike. While Hubble's visible light photographs revealed the beautiful clouds around the pillars, the actual process of star formation within them remained veiled. The James Webb Space Telescope, with its infrared imaging capabilities, has pierced the clouds to expose what lies beneath. Webb's photos show protostar clusters, enormous clouds of dust and gas many times larger than our solar system, forming tiny red dots against the pillar's murky backdrop. According to Bill Nye, protostars are stars in their early phases of formation. At this time, these young stars are not yet devouring hydrogen. However, as more material is sucked into their centers, they become denser and finally reach a critical point where hydrogen burning occurs, causing the star's temperature to rise to approximately 2 million degrees Celsius. Different colors were utilized in the illustration to depict the infrared wavelengths, which are mostly invisible to the human eye. The blue parts of the image are actually red. The wavelength of the hues in the image rises with radiation, with the red sections, such as the protostars, emitting radiation at a wavelength that is approximately 6 times that of the human eye. According to Bill Nye, this image not only demonstrates Webb's infrared capabilities, but also sheds light on the birth of stars like our own Sun. The search for exoplanets, or worlds outside our solar system, has been one of modern astronomy's most exciting endeavors. Since the first exoplanets were discovered in the 1990s, the field has proliferated, with over 3,000 confirmed exoplanets catalogued to date. However, the issue is not simply discovering these faraway worlds, but also observing them. Direct imaging of exoplanets has proven to be one of astronomy's most difficult challenges, with only approximately a dozen exoplanets successfully observed. This difficulty is largely due to the enormous distances involved and the overwhelming brilliance of their parent stars, which frequently outshine the planets by a factor of billions. Most exoplanets are detected indirectly, such as through the transit method, which detects a slight dimming of a star's light as a planet passes in front of it. However, the landscape of exoplanet research is rapidly changing due to the groundbreaking capabilities of the James Webb Space Telescope. Webb, which was launched with the promise of altering our understanding of the cosmos, has exceeded expectations. In September, the telescope made history by capturing its first direct image of an exoplanet, a big step forward in our ability to study these faraway worlds. The exoplanet, HIP 65426b, is a massive gas giant discovered in 2017. Unlike many exoplanets identified indirectly, Webb observed HIP 65426b directly with its advanced arsenal of telescopes. To accomplish this, scientists used Webb's coronagraphs, which are instruments designed to filter out the bright light from the exoplanet's host star, allowing the dim light from the planet itself to be identified. The telescope's exceptional sensitivity, paired with powerful infrared cameras and a variety of filters, enabled it to capture an image of this distant world with incredible clarity. HIP 65426b is an exceptional planet in many ways. It is almost 12 times the size of Jupiter, making it a true behemoth among gas giants. Furthermore, it orbits its host star at an incredible distance, 100 times that of Earth and the Sun. HIP 65426b's enormous separation from its star made it a good target for direct imaging, as the planet is far enough away from its star to be identifiable even with current equipment. The successful imaging of HIP 65426b is more than a technological accomplishment. It heralds a new age of exoplanet exploration. By taking a direct view of this faraway world, Webb displayed its ability to investigate exoplanet atmospheric compositions and possibly even weather patterns. Data collected from HIP 65426b has already begun to disclose previously unknown characteristics, providing insights into the genesis and development of gas giants in our galaxy and beyond. However, arguably the most intriguing aspect of this discovery is what it means for the future. HIP 65426b is only the beginning. The James Webb Space Telescope is poised to discover a treasure trove of exoplanets, many of which may lie in the habitable zones of their stars, the regions where conditions may be ideal for life to exist. The Phantom Galaxy, also known as M74, is one of the most captivating celestial phenomena observed by the James Webb Space Telescope. Despite its elusiveness in the night sky, the galaxy's brilliance is seen in Webb's infrared pictures, affording an unprecedented look at this cosmic masterpiece. While Hubble's optical photographs have long shown M74's exquisite spiral structure and the elegant dispersion of stars along its arms, Webb's newest infrared studies offer a completely new dimension to this galaxy. The most recent photographs from Webb's upgraded infrared cameras reveal complicated formations that appear like luminous fibers spreading from a brilliant central core. These threads, made of heat-emitting dust and gas, are portrayed in a striking electric blue, providing a stark contrast to Hubble's more typical optical views. This advance in infrared photography has allowed astronomers to see deeper into the galaxy's star-forming regions, which are spread throughout its spiral arms. Webb's capacity to capture the galaxy at many wavelengths has improved our understanding of these regions, revealing comprehensive information on the processes that regulate star formation. Scientists can obtain a better understanding of the properties of interstellar dust and gas by inspecting these star-forming regions with Webb's enhanced clarity. Researchers from the European Space Agency used Hubble and Webb data to generate a magnificent composite image of M74 to provide a more comprehensive view. This composite, a fundamental component of the high angular resolution in nearby galaxies international project, combines Hubble's optical clarity with Webb's infrared precision. The project combines observations from both space and ground-based telescopes with the goal of capturing infrared images of 19 neighboring star-forming galaxies. The combination of Webb's high-resolution infrared data and Hubble's optical images yielded a magnificent composite that emphasized the galaxy's rich architecture and dynamic dynamics. Webb's observations represent a big step forward in our abilities to study and understand distant galaxies. Webb's capacity to detect longer wavelengths of light gives astronomers a better tool for pinpointing star-forming regions than ever before. This, in turn, enables more precise determinations of the masses and ages of star clusters in these galaxies. Furthermore, the increased visibility of small dust particles in interstellar space contributes to a better knowledge of the galaxy's materials and the processes that occur within it. In July 2022, the James Webb Space Telescope, with its unparalleled imaging capabilities, focused on a faraway celestial object known as WR-140, a Wolf-Rayet star. The final image was nothing short of stunning, with Webb's trademark diffraction pattern, a starburst effect created by the telescope's hexagonal mirrors that appear as sharp spike-like lines emanating from the star. What particularly intrigued the scientific community was the intricate ripple-like formations surrounding WR-140, concentric rings that appear to defy traditional assumptions with their slightly angular, nearly boxy appearance. Unlike the diffraction pattern, these ripples were not imaging artifacts but rather true elements of the star system, indicating a more intricate tale. WR-140 belongs to the Wolf-Rayet star class, which is both unusual and interesting. These are enormous, evolved stars that have already shed a large percentage of their outer hydrogen layers, releasing them into space. This expulsion produces a turbulent environment rich in heavy components like carbon and nitrogen, which are blasted into space at incredible speeds. Wolf-Rayet stars are frequently found in binary systems, where their gravitational pull is strongly connected to that of a partner star. In the instance of WR140, it is this relationship that causes the unusual patterns shown in Webb's photograph. The concentric rings around WR140 are the consequence of a complex interaction between the Wolf-Rayet star and its smaller, less massive companion star. As these two heavenly bodies dance around one another in their orbital embrace, they cause periodic waves in the gas and dust surrounding them. Each time the stars get near together, the material between them compresses, forming a new ring. Over time, these interactions form layer upon layer of concentric shells that stretch into space. The form of these rings is very intriguing. Rather than being perfectly circular, they have a slightly boxy form, implying that the relationship between the two stars is more complicated.